Hello everyone, and welcome to our Seaborn Fundamentals lecture. In this one, we'll have a look at the basics of Seaborn, like how to import it, as well as have a look at some of the different plot types that we can use to visualize the distributions of our data. Let's go ahead and move on over into Jupyter Notebook and get started. Okay, so here I am inside of Jupyter Notebook. I'm going to go ahead and start by importing our libraries. For this lecture, I'm just going to import Seaborn, as we won't be using any others. And the typical convention for Seaborn is just SNS. So import Seaborn as SNS. As I'm working in Jupyter Notebook, I'll also just go ahead and say %matplotlib inline, like we looked at last time. One of the really helpful features about Seaborn is that it comes in with a few built-in datasets. So instead of us having to use lists and NumPy to manually generate some data, we could actually import one of these built-in datasets. To view all of the datasets available within Seaborn, we can say sns.get_dataset names, and this will return a list of all the different datasets that are available in our current version of Seaborn. So your list may look a little different to mine. I'm going to go ahead and grab this MPG dataset here. All we need to do is create a variable, which I'll call MPG, and then I'll say that this is equal to sns.loadDataset, and then we can pass in the name of the dataset from this list. So in this case, I'll pass in MPG. And then if we look at the head of this, we can see what our data frame looks like. And this MPG dataset just contains some information on different cars along with their miles per gallon, number of cylinders, displacement, horsepower, weight, acceleration, model year, the country, and finally the name. And just to confirm, we can see that this is a data frame by using the type function on this. With our dataset imported, let's go ahead and have a look at our first plot type, which will be a displot, which is short for distribution plot. And this is pretty much just exactly the same as a histogram, so it lets us visualize the distribution of data by categorizing it into bins. I'll go ahead and type in sns.displot, and then we'll have to pass in a single column from our data frame, as a histogram only works for a single variable. For this example, I'll pass in our actual MPG column from our MPG data frame, and then looking at the result of this, we can now see the distribution for our MPG column. The majority of our cars have an MPG of around 15 to 20, with a few outliers with a low MPG of 10, and then a few outliers higher up at around 40 to 45. And also, just to mention, we do have a warning up at the top here. Seaborn does tend to throw quite a lot of warnings, and this one is just telling us that we have some np.infinite or equivalent values inside of this column. If you want to ignore this error, we could import the warnings module and then say warnings.simpleFilter, and then for our arguments, we'll set the action to ignore, and then where the category is equal to future warnings. And then if we run our code again, we'll see that our warning has been filtered. And as I mentioned, warnings in Seaborn are quite common. But in the vast majority of cases, your plot will still work completely fine. If we wanted to reduce the number of bins in our histogram, we could use the bins argument like we used in Matplotlib. So I'll go ahead and copy this code for our histogram down into a new cell for our displot, and then I'll just say that bins is equal to 5. And then this time, our data will have been grouped into 5 much larger bins. The next type of plot that we'll look at in Seaborn is the joint plot. The joint plot basically allows us to visualize the distribution and relationship between two different variables. So let's go ahead and look at an example of this to see what it looks like in practice. To create a joint plot, we can say sns.jointplot, and then we'll have to provide three main arguments: our x data, y data, and then the actual data set that we want to use. Starting with the data set, I'll just set this as our MPG data frame. And then for this example, let's say that we'd like to compare the distribution between our MPG and vehicle weight columns. So I will set our x-axis to be our weight column, and then our y-axis to be our MPG column. When we run this, we'll get an output that looks something like this. And basically, what we've got here is just a scatter plot in the middle of our two columns, and then with a distribution plot or histogram on the top and right side of this too. If we have a close look at the data for our scatter plot, this does make sense, as it shows that the heavier a vehicle is, the lower its miles per gallon, and vice versa. Off to the right, we get a histogram which shows us the distribution for that column. When we looked at the distribution of our MPG column before, we saw that 15 to 20 was the most common value, and that's the same with this histogram here too. And then the histogram on top is just the distribution of our vehicle weights. Joint plots can also take an additional argument, which is the kind. And this will allow us to customize what gets put in the middle of our joint plot here, which is currently a scatter plot. So by default, the kind argument has a value of scatter, but we could also pass in another kind such as hex, which will show the same data, but in a slightly different way. Whereas before, we got to see the individual data points, with hex, we get a few different hexagons, and basically, the more data points that are in that area, then the darker the hexagon is. And then, of course, the less data points that are, then the lighter the hexagon. There are other options for our kind, but in the vast majority of cases, you would just use scatter. Let's expand upon our joint plots, and then have a look at a new plot type, which is the pair plot. Pair plots allow us to visualize the relationships between different variables in a dataset. So basically, pair plot will plot every single relationship for every numeric column in our data frame. Or in other words, it'll create a joint plot for all of the combinations of our numeric columns in our data frame. We'll go ahead and say sns.pairplot, and then I'll pass in our entire MPG data frame. And then if we run this, it will take a few moments to run, as it's creating quite a lot of different plots here. And okay, so this is a pair plot for our MPG dataset. And basically, as I mentioned, a pair plot is just a joint plot for every numeric column in our data frame. There's actually a few too many columns in this data frame to really see what's going on. So let's go ahead and import a different dataset, which will be a little smaller and easier to see what's going on. I'll import the tips dataset, which is again part of the Seaborn built-in datasets. So I'll just say that tips is equal to sns.loadDataset, and then the dataset itself is just called tips. And then looking at the head of this is what the data frame looks like. So it's just information on the tip amount and total bill for orders at a restaurant. If we call pair plot again, but this time on our tips dataset, it's a bit easier to see what's going on. And basically, we just have a plot showing the pairwise relationship between each numeric column in our data frame. So each numeric column is getting compared with each other numeric column. For columns where it's comparing itself to itself, for example, for our total bill on our x-axis and y-axis, so this top left one here, it actually plots a histogram showing the distribution of that column. And then for the other combinations, it'll show a scatter plot. So for this plot here, with the total bill and tip, we can see that as the total bill increases, then so does the tip, which makes sense as typically a larger total bill goes hand in hand with a larger tip. So pair plots are a great way to quickly get an overview of the numeric columns in your dataset. To add to our pair plots, we could also add in the hue argument, which, as we can see from the documentation here, this allows us to specify a variable to map different plot aspects to different colours. So in a simple sense, this just allows us to colour the data points or elements in our plot based on the different levels of a categorical variable, which is very helpful for visualising how the relationships between our variables differ across categories. To look at an example of this, let's say that we want to see how these different columns are related to each other, but also broken down by the sex column. So at the end here, I'll just go ahead and pass in hue is equal to sex, which is one of the columns in our tips data frame. And then when we run this, that will color code our results by the column that we just set for our hue. So the sex column. All of our blue data points here is the data for males, and then the orange data is for females, which we can see from our legend off to the right. We could customize these colors by adding in some additional styles or specifying color palettes, but this is something that we'll look at later on in the section. For now, we'll just move on to our next type of plot, which is the rug plot. Rug plots are a very simple type of chart, but they do provide us with a very helpful and powerful way to analyze the distribution of our data. What they do is basically place a small tick along an axis for each occurrence of a data point. The greater the density of ticks, then the greater the distribution for that value. To create a rug plot, we can call the sns.rugplot function, and then like our displot for our histogram, this function will only take in a single column from a data frame. I'll just pass in our MPG column from our MPG data frame, and then looking at the result of this, all this is doing is plotting a little line or tick at each data point in this column. The more ticks in a particular area, then the more common that value is. We know from before, when we looked at our histogram, that 15 to 20 is our most common MPG range, and we can see this reflected here on our rug plot, as this is the area that's got the most ticks. So they show us the same data and result as a histogram, but just in a slightly different way. And this then brings us nicely onto the final plot type that we'll look at in this lecture, which are KDE plots. A KDE plot, short for kernel density estimation plot, visualizes the distribution of data in a similar way to a histogram, or displot as it's called in Seaborn, but it utilizes something called kernel smoothing, and basically, in a very simple sense, all kernel smoothing does is average nearby data points to reduce the noise and peaks within a dataset. We can go ahead and call sns.kdeplot, and then I'll pass in the same MPG column from before, and this will then pretty much just plot a line which resembles the shape of the histogram that we created before. We're not going to go into too much detail on KDE plots, as they are more useful and related to data science and machine learning, but I still wanted to just introduce them. And also, just to show you, if we create another displot here, then we can see that these two do have a very close relation to each other. But we could actually plot a KDE line on our histogram by passing in the KDE argument and setting it to be equal to true. And then this will plot the exact same KDE line, but actually on our histogram, which, as we can see, does smooth out some of the noise and peaks that are present on our histogram. Okay, so that's it there for our first main theory lecture on Seaborn. In this one, we've had a look at the main types of distribution plot within Seaborn, which were the disk plot, which is basically just the same as a histogram. Then we had a look at the joint plot, which allows us to visualize the relationship between two variables, the pair plot, the rug plot, and finally, our KDE plots. Hopefully, you can see how powerful and easy to use Seaborn is. It allowed us to create all of these different plots with just a single line of code, as opposed to Matplotlib, which took multiple different functions and methods across different lines. All of the knowledge that we gained in the last section won't be wasted. Matplotlib is still a very helpful and necessary skill to have, and a lot of it will transfer over to Seaborn, which we'll see later on when we come to customize and style our Seaborn plots. In the next lecture, we'll begin looking at our next type of plot, which will be categorical plots. So I'll see you all there.